This noodle cup is steaming hot, and millions are created in factories and ship around the world each day. There's no stove, no fire, and no microwave. So, what's going on here? You're looking at one of the wildest inventions in modern food tech, self-heating instant noodles. And today, we're heading straight into the factory where these hot meals are born. From flour to flames, well, chemical flames, you'll see everything. Before we dive in, let me ask you this. Have you ever tried one of these, or would you? Let us know in the comments below. And if you're into satisfying factory videos, hit that subscribe button. You're gonna love this one. Self-heating food packs were first developed for soldiers in the field, where heat is a luxury and warm meals are fuel for survival. But these little wonders didn't stay in the army for long. By the early 2000s, they hit camping stores. And by the 2020s, bam, they were everywhere, especially in Asia, where instant noodles are practically a food group. Here's a fun fact. In China alone, over 4.5 billion self-heating meals were sold in a single year. That's more than the population of the entire planet. It all starts with the basics, flour and water. The dough mix is simple, but the process is anything but. These factories don't mess around. The flour's sifted, tested, and loaded into automated hoppers that can handle hundreds of kilos per hour. Then come the stars of the show: dried vegetables, meat chunks, soup bases, and seasoning oils. Now we move to the noodle lab. Dough is kneaded under industrial pressure, pressed into giant flat sheets, then cut into ribbons. Next, steaming. Each noodle batch is steamed at 100 degrees Celsius to lock in the structure. Then they're either air-dried or flash-fried, depending on the recipe. Do you know that flash frying at 140 degrees Celsius dehydrates the noodles almost instantly, boosting shelf life up to 18 months? Quality control. Noodle strands are randomly sampled for elasticity, color, even bounce rate. Yep, noodles are bounced to check for chew. Let's talk flavor. The soup base is where the magic happens. Factories use high-speed emulsifiers to blend oils, spices, chili pastes, and fermented ingredients into thick, punchy sauces. Freeze-drying preserves 90% of the food's nutrients, and the crunch. Some soup packs have over 30 different flavor compounds. The soup is so flavorful that it mimics slow-cooked broth that takes hours to prepare. The toppings and seasonings are packed into individual sachets by automated sealing machines that work at lightning speed, around 200 packs per minute. Time to put it all together. First goes the noodle block, then the dried toppings, then the seasoning packs and instruction cards, all perfectly layered, because if one piece is misaligned, it can mess up the heating process. Then the lid goes on, sealed with a high-temperature press. And it's fully automated. One technician oversees dozens of robotic arms across a production line stretching over 50 meters. Here's the part everyone wants to know. How does this thing heat itself? Meet the self-heating pack. It's tucked at the bottom of the meal or in a separate chamber, and it's filled with a common chemical called calcium oxide, also known as quicklime. Now here's where the magic happens. When water is added to calcium oxide, a chemical reaction takes place. It's called an exothermic reaction. That just means it gives off heat. In simple terms, think of it like this. Calcium oxide is super thirsty for water. When it drinks up the water, it gets really excited. So excited that it starts to vibrate and release a ton of energy in the form of heat. That's what makes the steam. Why, you can literally watch the temperature shoot up to nearly 95 degrees Celsius. That's hot enough to cook noodles or even boil water. Here's a fun fact. This same reaction is also used in construction to make cement. But in your noodle cup, it's like a safe mini furnace. The noodles go up top, the heating pack goes below, and between them, a thick, food-grade barrier that keeps heat flowing without contact. Each heating system is pressure-tested in-house. That means thousands of packs are checked for leaks, cracks, or weak reactions before shipping out. We're approaching the finish line, but let's pause for a moment and talk numbers, especially in the US market. Once each cup is sealed, it's wrapped in a tamper-proof sleeve. These sleeves include clear cooking instructions, safety warnings, and expiration info, all critical for consumers. Did you know some factories ship over 1 million cups per month? And yes, a big chunk heads straight to the US. Here's the real eye-opener. In 2024, the US self-heating food packaging market, which includes everything from noodles to hot pots, was valued at roughly $17.9 billion. That makes it one of the biggest national markets, representing around 40% of all North American sales. And the segment is still growing, projected to reach nearly $27 billion by 2034, with a steady 4.2% annual growth rate. So these noodle cups aren't just snacks, they're part of a fast-rising food trend catching on across college campuses, offices, and campers in the US. Once sealed and labeled, cups are grouped by batch and palletized for shipping, ready for highways, warehouses, and eventually your grocery store shelf. So next time you peel off the lid of a self-heating noodle cup, just remember you're not just eating lunch, you're firing up a portable chemistry set. Which part of the process blew your mind the most? The 95°C reaction, the freeze-dried meats? Drop it in the comments below. And if you loved seeing behind the curtain of how stuff gets made, subscribe for more deep dives. See you in the next one.